All right. Well, we're going to start normal distribution today, and we're going to be using standard deviation, what we were calculating last week. We're going to be really focusing on the technology because this aspect of it, we really don't want to do by hand, and IB is not going to require you to do it by hand, and I'll talk about that part of it when we get there. But just a few housekeeping items. This Thursday, you're going to have your next quiz over standard deviation. Okay, so you are going to be able to do everything on the calculator. You're not going to have to do it by hand. So you definitely want to know the keystrokes in order to pull that up to answer all the questions, both the mean and standard deviation. Okay, the other one, the big one we want to be looking ahead towards is going to be the second exam. That's going to be on Monday the 17th. So actually the next time we finally meet on a Monday is going to be our next exam. So basically 2 weeks from yesterday. Speaking of the first exam, when is the deadline if you wish to retake to raise your grade to a 70, if anybody happened to fail? Okay, well, I'm glad we're talking about this. It is Tuesday, the 11th, so you still have a week. Normally, it's a week after I go ahead and give those. We gave it last Thursday, so it would be this Thursday, but we weren't here on Monday. We're not going to be here this coming Monday, and I'm not here this Friday. I have a workshop that I have to go to, professional development. It's going to be super fun. Yep, and I mentioned that, right?
It's on the website.
It is on the website as well. Okay. I couldn't remember if I actually mentioned it in class. But what you're going to be doing that day, I mean, I don't know if the substitute is going to have a background in mathematics. Maybe, maybe not. You know how it goes with substitutes. They're probably going to be specific to some field, just not what we do in here. If they are, fantastic. But the homework that I'm going to go ahead and give you guys over this, I'm going to leave for the substitute on Friday. And I'll go ahead and mention this again over the next couple of days. But that's what you'll do on Friday. You can help each other out. You'll have the entire period. And then Tuesday the 11th, you'll go ahead and turn those in. Yes? Then let me know on Thursday and I'll get you a copy. Mm-hmm. All right. Or if something comes up and you thought you were going to be here and you suddenly weren't able to, what can you do?
Go on the website.
Website. The website always has all the notes, assignments, everything you need. All right. Well, let's go ahead and get started. We've seen examples of positively skewed, negatively skewed, and symmetrical distributions. I've kind of talked about them briefly. I haven't gone into them in a whole lot of detail. But on that first assignment, we did see one that was positively skewed. But here's the relationship when you're looking at these types of graphs. If it's a normal distribution, this is what we call the bell curve. Okay, symmetrical distribution, about the middle. This is where the mean, the mode, and the median are all the same value. Okay, the mean, median, and mode are all the same value. If you have a graph that's pushed to the right, what we call negative side is stretched, or negatively skewed distribution, this is where the mean is less than the median, which in turn is less than the mode. Okay, so the mode will be the largest and the mean will be the last. Again, the median is still going to be in the middle. And just the reversal, when we're talking about a graph that's pushed to the left, this is what we call positively skewed distribution. All right. Here, the mode is less than the median, which is less than the mean. So if it's negatively skewed, the mode is going to be the largest value. If it's positively skewed, well, then the mean is going to be the largest value. Either way, the median is still going to be the middle value. So here's what we got here. Here's our example, because we're going to be using this curve to help us with probabilities. We're going to be finding the percentage of determining a certain element of your set within a given region. Okay, so let's start at the beginning. The mean is right here in the middle, and you'll notice up until now we've used x with a little bar above it to represent the mean. Okay, but now that we're talking about standard distribution, we're going to use this lowercase letter mu. Okay, looks like a U with just the front part of it extended down a little more. Okay, we call that mu. That also represents the mean. Now, in a standard, a normal distribution like this, we like to show standard deviations 3 above and 3 below, what we call within 3 standard deviations. So if you're taking a look at your graph here, remember, we're still using the same symbol for standard deviation, okay, the lowercase sigma. So the first standard deviation is to take the mean and add that value. Then we have the mean plus 2 times the standard deviation. And then finally the mean plus 3 times. So that's if you're going above. Now, what do you think you're going to be doing if you're going below? Yeah, you're going to be subtracting. So you subtract 1 standard deviation from the mean, then you subtract 2 times the standard deviation, and then you subtract 3 times. Now the values that you see here in your table, this is actually what we use in statistics. Okay, in fact, I've got these right up here. 68.3% of all of your elements in your set are going to lie within 1 standard deviation. So the majority of your set's going to be right there. 95.4% will be within 2 standard deviations, and 99.7% will be within 3. We're talking about the area under the curve here. So IB doesn't have you use those decimals exactly. IB kind of changes it around a little bit. So you only have to worry about these 3. 68%, 95%, and then 99.7%. The only decimal they require you to know for normal distribution is going to be the 99.7. Okay. Oh, shit. So what we're saying is within 1 standard deviation, we should be seeing 68% of all of my data below the curve. Okay. So let me backtrack before we go ahead and start to put these in. Let's say something simple. Let's say we have a mean of 15. Okay. I'm just going to make up some kind of number. And let's say my standard deviation is equal to 3. Okay, nothing big. So that means the values are not very spread apart. Okay, they're much closer together. So 1 standard deviation above would be 18 because I took the mean and I went ahead and added on 1 standard deviation. Within 2 standard deviations, this would be 15 plus 3 plus 3. So what would that be? 21. Yeah. To go above, you're just going to add your standard deviation. So when I get to mu plus 3 standard, then that would be 24. Okay. And now to go in the opposite direction, we just go ahead and subtract them. So 15 minus 3, 12 minus 3, and then minus 3. There you go. And then you'd be asked certain questions about this. What's the probability of finding a data set within 1 standard deviation? Okay, we're going to look at some examples in just a second. But is everybody okay how you set up your diagram? Okay, once you're given the mean and standard deviation, you have everything you need. Okay, well now let's go ahead and break down all of our percentages here. So we're not worried about these guys. According to IB, within 1 standard deviation, we should see 68% of the data. But now remember, this is symmetrical. So what do you think about this area compared to this area? They're going to be exactly the same. Yeah, if I were to fold it right along the middle, the 2 sides are going to come together perfectly. We say they coincide. Have you guys ever heard that word before? Coincide? Okay, good, good, good. And it's also what you should do when it rains. Coincide. I got a million of them. Okay, so if these 2 areas are the same, well then what's 68 divided by 2? 34. What? 34, there we go. Because see, we're not going to worry about the exact decimals that we're supposed to be looking at. For IB, we can say each of these areas is 34%. Okay. All right. Now, your table has the exact areas, but IB doesn't require you to know those. Okay, and that's actually pretty good. I know that this coming summer, I'm going to have to go to another workshop training for IB because they're changing up the program. Maybe that's one of the things they'll change. I'm actually kind of curious to see if they're going to make you start finding z-values on these numerical tables. You probably don't know what that means, and that's okay, but right now just be thankful you don't have to do that. Okay, it's not difficult, it's just very tedious. All right, now within 2 standard deviations, what percent of my data should be below the curve? 95%. So here, this should be 95%. But now we've already accounted for 68% of it, right? I know that this little area is going to be symmetrical, congruent to this little area right here, right? So first off, what's 95 minus 68? 27. So I need to divide that difference by 2 because these areas are congruent. So half of 27, 13.5. So this would represent 13.5% of the data, as would this. Okay. Is everybody okay with where I'm getting these numbers from? Any questions? Okay. And now within 3 standard deviations, this is where you're going to have that 99.7% of the data. Okay, so virtually all of the data, okay, is going to be contained below this normal distribution curve. Okay, so let's see here. What's a 68, or well, we don't have to add them up. We'll just take the difference. I need a 99.7 minus 95.
Or 4.7.
Okay, so you're saying 4.7? Now I've got these 2 little areas right here, this guy right here, and this guy right here. So take that percentage you just gave me and divide it by 2. 2.35. Because it said 4.7, right? So it'd be 2.35. So see, the decimals are slightly off what we actually should be looking at, but not enough to cause any major problems. So this little area right here would be 2.35%, as would this guy right here. 2.35%. But if you realize that within 3 standard deviations, everything should be 99.7, you should be able to go back, without even memorizing it, and just kind of figure out what those individual percentages would be like we just did. Or maybe if you want to memorize it just to make it more efficient and faster, who wouldn't? Hey.
So then, what are the questions that we would be getting on the test?
Okay, excellent question. We're going to go ahead and get to one in just 1 second. Okay. So before we go ahead and actually get into some examples, is everybody okay with the normal distribution? Now, we're not going to be doing anything with the negatively skewed or the positively skewed. I'm just kind of putting that there so you can just kind of notice it. And if you ever see that, you'll recognize what it is. But, if you remember back to the first week, there's so much we have to cover in here to get you guys ready for the paper exams. We really don't go in a whole lot of depth. That's where I think, I wish we could, change things. Because I'm sure more than anything, you guys want to do this in depth, right? Absolutely. Let's get it done. Stat. Because it's statistics. Yeah. Okay. Hey, look, there's a problem. Okay. So let's take a look at a problem here. So here's how a normal question could potentially be asked of you. It says, the chest measurements of 18-year-old male footballers are normally distributed. So normally distributed, that means you've got that bell curve graph we were just talking about. Okay, that rings a bell. With a mean of 95, so here's my mu, and a standard deviation of 8 centimeters. Okay, so it says draw a normal distribution curve and label it with a mean and 1, 2, and 3 standard deviations above and below the mean. Okay. I'll do this because I want my graph to look somewhat decent. And there we go. Okay. There we go. So there's my bell curve. Okay. Now my mean was 95. So right here in the center, if I can draw a straight line, that'd be fantastic. It's not bad. There's my 95. Now I want to go 3 standard deviations above and below. So I'm going to go ahead and draw my 3 lines. So here's the 1, here's the 2, here's the 3. Here's the 1, here's the 2, and here's the 3. All right. Well, if I know that the standard deviation is 8, then what would I put right here?
103.
103. Okay. Above, you want to add the standard deviation. Below, you want to go ahead and subtract. Okay. So 95 plus 8, this would be 103 plus 8. 111 and plus 8. 119. Okay. And then now let's go back in the opposite direction. 95 minus 8. 87. 79. 71. Okay. All right. And let me go ahead and run through very quickly. Let's see, without looking at the diagram that we just drew, not this one, the one above higher on your page. Try not to look at it. I'm just going to go ahead and put in these, but I'm going to call on certain people. Alejandro, okay? What percentage of the data would be between 95 and 103? 34%. Okay, very good. Evelyn, what percentage of the data would be between 79 and 87?
13.
13 point something. We're so close.
5.
5. There we go. 13.5%. Good. And within 3 standard deviations, help me out, Libby. Without looking.
2.5.
She's so close. A little less than 2.5.
Point.
You want some help?
2.35.
2.35. There we go. All right. So this is 1, 2. So this isn't the same as the one I just drew. Okay. It's a little off, but you get the idea. So 2.35. So we have everything we need. 34%. This would be another 13.5. And then this would be 2.35%. And of course, it's not to scale. I just sketched it. Yes?
It's always just the same number.
The same percents. But the numbers along the bottom are determined by what you're given. Okay. So it depends on your mean and what the standard deviation actually is.
And when we have problems that are not normally distributed, we have to find out.
Now, for everything we're going to do in here, we're going to believe everything is normally distributed. Now, it's true if data is not normally distributed, if it's like positively or negatively skewed, you can basically force it to be normally distributed if you wanted to, so that you can analyze the data better. But that's not something that IB requires us to do. We're just going to go with the idea that everything is already normally distributed. We're going to make it real easy. Okay. All right, so here are some questions. First off, is everybody okay how I got the numbers at the bottom, where I got the percents from? Good to go? Okay. Well, B, it says find the percentage of footballers with chest measurements between 87 and 103. There you go. Because see, that's within 1 standard deviation, both above and below. All I did was take from where they told me to start, where they ended, and I just added the percentage. So 68% of the footballers should have a chest measurement between 87 and 103. Is everybody okay with this? Okay. All right. Well, let's try this one. Find the percentage of footballers with chest measurements between 103 and 111. There you go. So only 13.5% of all these guys whose chests were measured should fall between 103 and 111 centimeters. Okay. How hard is this?
Now I started.
Easy, right? If you know that curve, it's going to be so simple. Remember, it's 68, 95, and 99.7. That's the only decimal originally that you have to know. Okay, well, let's do this. Find the probability that the chest measurement of a randomly chosen footballer is between 87 and 111. So this time I'm going 87 to 111. So what would I do?
Add 68, 113.
There you go. 34 plus 34 plus 13.5. So I want to take 68, 13.5. So I'm looking 81.5%. Okay. How we doing? Okay. Now here's the trick. If everything was within a standard deviation, like we're asking here, we have no issues. If it's not using the standard deviation at the bottom, that's when we're going to have to do something different. Okay, so let's take a look at our next problem. Okay, in most instances, we are not going to be lucky enough to be looking for probabilities that are exactly 1, 2, or 3 standard deviations from our mean. Okay, because in real world, there's all types of values and circumstances that are going to happen. Now, to determine the probabilities for these situations, we can use a table of standardized normal variables. We call these z-scores. So basically, you would need to be provided with pages of just numerical values categorized horizontally and vertically so that you could determine what the probability was going to be. This is how we used to do it way back in the day before technology. Luckily, IB is not interested in you using z-scores. Okay? We don't have to go ahead and do that. In fact, the formula for it, if I remember correctly off the top of my head, z is going to be mu minus the estimated value divided by the standard deviation. Okay, so you'd actually have to do a little bit of digging on your table to figure out what the answer was going to be. What we're going to do is use technology. Okay, it's going to be made so much easier. So you just have to know the keystrokes. This is just something you'll want to remember. So let's try this. Using the information for footballers above. Okay, so let's go ahead and remember this. What was my mean? It was 95. And what was my standard deviation? It was 8. Okay. So using that information from above, determine the probability that a randomly selected footballer has a chest measurement between 88.2 and 94.7. So 88.2 and 94.7. Let me call them back over here. Okay. Let me go ahead and use a different color. So 88.2, might be somewhere right about here. And what was the other one? 90 what? 94.7? So maybe really close to that guy right there. If I could draw a straight line, that'd be great. But obviously it's not going to happen today. But you can tell, you can probably estimate, it has to be less than what? Has to be less than 34%. But there's no way on here, if they're not using the exact standard deviation, that we can go ahead and calculate that. So we got to go with the technology. All right, so here is what we're going to do. Now, we have a lower boundary and we have an upper. So I'm going to go ahead and label these. This is my lower, and this is my upper. And when you're dealing with normal distribution and you want to find these, that's how you want to label your values. And I'm actually going to show you the notation we use to write this if they want to do so in just a minute. So here's what we're going to do. Let's go on over to the calculator. Oh my gosh, is it already 1:56? Doesn't time fly when you're having fun? I mean, this is just a ball, right? Okay. Let's see here. All right, so we're going to go to your scratch pad. Okay, just a normal everyday scratch pad. Okay, so Eli, do you already know the keystrokes?
Yeah, wait, when you go to scratch pad, you calculate?
Oh, no, yeah, scratch pad is just like calculate, yeah. This is where you do all your normal calculations. I know that some people like to go ahead and open up a document and they go ahead and do their calculations there. I mean, I've never done that. It should still work, but does it still work? Okay. Yeah, this is what we refer to as the scratch pad. Basically where you do all your scratch work. Okay, so I'm going to go to menu. Okay. Now we're going to go to statistics. Okay. Distributions. And here's what we need. You'll notice there are two of these, a normal PDF and a normal CDF. We want the normal CDF. Okay. Alejandra, do you agree? She does. Okay. So let me go back. Let me escape. Let me escape out of here. All right. So I went to menu, and maybe you want to jot this on your paper someplace. Okay. So from your calculator screen, your scratch pad is what I'm calling it. Where did I go? Menu. Statistics. Now see, we're not going to stat calculations because we actually don't know what the data is. We're going to distributions because remember, we want a normal distribution, right? So that makes sense. And then what do we want here? Normal CDF. We don't want PDF. That is something different. Okay. So what we're going to do, as soon as I click on that, it's going to bring up this table, and you'll notice the first two rows are going to be your lower and your upper bound. Okay, so let's type in, we wanted our measurements to be between, was it 88.2? Okay, so I'm going to delete that, if this will allow me to. So I'm going to type in the 88.2, tab, the upper boundary. 94 what? 94.7, okay. And then right here, my mean was 95, that's my mu. Okay, but we already knew that. Oh, does it ever stop? Okay. And what was my standard deviation? 8. Okay. So as soon as I go ahead and click enter, or OK, there we go. It'll give me the percentage I'm looking for. Well, now, this is the decimal. You'd have to multiply by 100 or just move the decimal over. So I'd say about 28.7%. Okay. And does that fit with what we know about the curve? We knew it had to be less than what? 34. Okay. So 28.7%. And that's all you got to do. Okay. Yes, ma'am.
Is there a way to do this without online clicking?
Oh, yes. Did you want me to show you?
Yeah.
Do you really want to know? Because it's way more difficult.
I kind of.
Okay. If we have time, I would love to go ahead and show you guys. Or maybe I can make a video of it. You know, a bunch of you get together on Saturday night. Yeah, let's do this.
Do it.
I don't know. We'll see. Yeah, we'll see. There you go.
And then we'll watch the video.
You'll watch what?
Then we'll measure our dog's shoulders.
There you go. Measure the dog's shoulders.
Dude, I feel like we have a purchase.
There you go. Okay. So let's go ahead and try the next one. So I want to determine the probability. So we're looking for the percentage of the football players who has a chest measurement smaller than 96. Now you'll notice this isn't written out in the notation. I haven't even shown you the notation yet. If you want to look ahead in your notes, you'll be able to see it. But what would you consider this to be? The lower or the upper boundary?
Upper bound.
Upper, because we want everything smaller than 96, right? So this is my upper. Okay. So I'm going to go over here again just to go ahead and show you this graph. We want 96 centimeters. So 96 is going to be just past halfway. You know, I'll go ahead and do a wiggly line right here just to distinguish it from the others. So about right there. Okay. So we would want to add the 2.35 plus 13.5 plus 34 plus whatever that other little percentage was going to be. So we can have an idea. We can already get kind of close, right? But let's go ahead and plug it in the calculator. Okay. So I'm going to come on over here. And here's something that you're going to have to do. And this is going to come up more so tomorrow, but your calculators are only capable, especially when the inverse, of doing less than. Okay, and you'll see what I mean when we get there. But let's go. So I remember it was menu, statistics, distributions, normal CDF, not PDF. That is something different. Okay. Now, here's the thing. It'll always start up by giving you a lower boundary. Okay. So if you simply want less than a particular value, you're going to leave that exactly as is. Because what does that E mean? Yes, that's times 10 to that power. Does anybody remember what we call that? Scientific notation. So that's actually an extremely small number. So if they already give that to you, perfectly fine. Just go ahead and let it go. So I'm going to click tab. Now my upper boundary, what was it? 96? 96. My mu was 95 and my standard deviation was 8, right? Okay. So what percentage of the football players had chest measurements less than 96? I'd say about 54.9. Now, because it's 0.97, I would be perfectly fine if you said 55.0. Okay? Or just 55, you know, we're talking sig figs. But I do want to go back and show you very quickly something. And then we'll go ahead and stop for today. We'll actually use C as kind of a review to start off the lesson tomorrow. So we're going to menu, statistics, distributions, normal CDF, not PDF. Now, let's say you want a number larger than a particular value. Okay. Like, let's say we want to give me a value that we could work with this table. 92. Let's say we wanted the percentage of all the football players' chest measurements that were above 92%. So if you want to go above, that means that 92 would be your what? Would be your lower. Now, here's what you're going to have to do. You'll go ahead and put in your lower boundary, but you have to put in an upper boundary. Okay? But this is, again, make it really easy. All you got to do is fill it up with 9s. Because you just have to put in a number that's so ridiculously big, the calculator will say, okay, I'll do this. That's basically what it comes down to. Okay. Now, if I go ahead and put in my mu and that, then I would say close to 65% of those guys have chest measurements bigger than 92 centimeters. Okay. So you have to be thinking with the normal distribution, are you going to categorize it as an upper boundary or a lower boundary? That's what we're looking for. Okay. All right. And we'll go ahead and stop there. Thank you very much, guys. You did a great job today. Yes.